going to have a talk about py.test in a minute, but first the hotel has asked me to let you guys know that they've opened up the dinner buffet at 5 o'clock. So if you're hungry at 5, it will be open just for us. So that's very exciting. Right now we have Brian Dorsey and Maciej Fijalkowski and the talk on py.test.
Great. Hello, everyone. I'm Brian, and this is
Maciej.
And we're here for this. So quick question first. How many people here have ever done unit testing? Yeah. OK. Using unit test? Using py.test? Using nose? Doctest? Sweet. That's very good. So we're going to do kind of first half of the talk, kind of quick basics of py.test, and then move on into much more advanced stuff. As far as who we are, actually, we should mention that the third person mentioned on the program, Holger Krekel, could not make it, which is very unfortunate since he's the author, the primary author of py.test and pylib. Maciej is the author of most of the advanced features that we're going to talk about today, and I'm just a happy user. So take whatever I say with a grain of salt. Yes, so it is a general purpose testing tool, mostly for unit-like tests. Primary benefits of being just minimal extra code. For the most part, your tests can look like application code with an assert statement. Yeah. Let's see it. Which lets you get in the thinking of your application writing even earlier. So if you're a TDD fan, that can be really cool. So these are actual py.test tests. The first one should work. The second one should fail. Third one should print some stuff. And this is tests in a class. So you can have standalone functions. You can have them in classes. When you use classes, I'll talk about that later. And some of the features were inspired by features needed for the implementation of PyPy. But it is a completely general purpose tool for whatever you need. So the actual overall tests are almost identical to nose. In fact, about 80% of the things you write for py.test can be successfully run under nose test and vice versa. And we're actually hoping to make that a little closer, see what happens. As you can see, to make a test, you just name it test and foo, and anything that is test underscore something will get found automatically and run. Setup and teardown, we can do that at the module level for your whole test module, and then when you have classes at the actual class level. And yeah. And generative test magic. So if you have a whole series of nearly similar tests you need to run that just vary in their input value, you can actually just write that once, pass the actual data into the test, iterate over them, and every yielding will be run as an individual test, which you get full, nice traceback on as if it were an individual test. And this is like one of my favorite things compared to unit test is you don't need to do any boilerplate or any runner. You just write your tests and run py.test in that directory. It will find all of your tests by the names and run them. Yes? And if you want to see which tests it would run if it were running, you can run this collect only bit, and it will show you exactly which tests and where they were located and that sort of thing. I think we might be at the maximum.
Yeah. Just directories, modules, and functions. That's the important part. That you've got directories inside their modules, inside their classes, and inside their functions. Nothing fancy.
Okay. And so the normal actual testing bit of py.test is the assert function. So you get rid of all the assert this, that, and the other, and you just write assert, and then something that will evaluate to true or false. Anything, normal code. And the thing that makes that work is that py.test does reinterpretation upon failure and introspects the current running state, figures out what the variables were, and prints all that information out. So let's take a look. So for the test that failed, you can see the actual assert line is just assert that. It raises an assert error and says, oh, actually, 3 does not equal to 4, where 3 is that, and the right-hand side was actually that len mark. And it does that for arbitrarily complicated pieces of things and ends up working. It works really nicely, and occasionally...
Occasionally it fails when expression is sophisticated enough and put on multiple lines and stuff like this, but usually it works, like 98%.
And that gets into the just magic. And then this piece, combined with that, in your test yourself, you just print out the value of anything you want all the way through the tests. And if the test passed, you'll never see the output at all. So you leave all of your debug prints in, and when they fail, boom, you get full details of anything you might want to know in addition to what py.test automatically prints for you. Yes, and plus there are options to actually control that. There's a few corner cases where hacking standard in, standard out like confuses tests or libraries, and so in that case you can actually turn that magic off. And since full test suites can get pretty long, you can actually determine which tests you want to run. If you want to run a subset, you're working on some particular part, you can actually just pass the test file name into py.test, or you can say, I want to look at tests that have this text in their name, that sort of thing.
I've got a hack here, so if I say run the test 1, I can say -k, which will select test on keyword. I've got tab completion, which lists all the tests. It's very cool.
And I think that's all bash completion magic?
Yes.
Cool. So a little extra fun for people. And yeah. And test selection and installation. So if you guys like easy install, you can easy install py, which will give you the entire pylib, including py.test. It will include the py.test in your Python scripts directory. So if that's in your path, it'll end up working. That's even true for Windows people, but instead you type py.test instead of py.test. And SVN trunk tends to be very stable. I've been running out of SVN trunk for a long time. Yep. And now we'll move into some advanced features.
Okay, so we've got, for the purposes of the JIT actually, testing JIT of PyPy, we developed ad hoc test distribution, which means that we can run tests over multiple platform, single platform, but multiple machines. So if we have tons of tests which runs for hours, we just run them on distributed setting. It's different than BuildBot because what we do is we rsync the current working copy. We don't need to commit before actually testing this stuff. It's very, very cool. Test before commit, not test after commit. I've got here a little demo. So say I go, here. It's the pylib testing suite on its own. And I run it with the next cool feature, the web backend that shows reporting of tests. So this is all reporting of tests. Actually, I don't know CSS that much to make it fancy, but it works. Oh, some are failing even. Oh. That's solely for the purposes of the show. Okay. So this is the web reporter. If somebody knows CSS and wants to help, it would be very good. Actually, it's implemented using PyPy's JavaScript backend, so we wrote all code in Python instead of JavaScript, but I don't know if it's a good idea. Just a test for the JavaScript backend itself. Excellent, you can tell.
Okay, so in addition to that fancy stuff, you can actually create simple plugins for executing your own specialized testing through the py.test framework. So you can create a little plugin and say, oh, by the way, I also want to look at all the txt files or rst files in this directory and run them through a REST validation to make sure they're all valid REST. Or I'd like to, say, run all of the txt files through doctest and have them actually get executed in doctest, but reported through py.test, so all my tests run through the same suite.
Okay, so some of these extensions are PyPy specific. I mean, the concept was developed for PyPy purposes. We use it very extensively. Like, we've got nightly test runs that run all the tests on different platforms, things like that. I don't have network here, so I won't show you the buildbot. But you've seen buildbot. We've got buildbot hooked in different way. Next slide. And for example, we can run ECMA test suites for JavaScript for testing JavaScript interpreter. So we run snippets of JavaScript through py.test, and it's possible as well. This is the feature on trunk only, because distribution of tests in the release 0.9. It has been there for a while and works pretty stable. We've got something more interesting, which is reporter hooks. So basically, parsing output of testing tool is not a good idea in general. The exact output might change between terminals, might change in time, and it's hard to rely on that. So we've got API that hooks into reporting part. So instead of printing and parsing it afterwards, buildbot just hooks small stuff inside and runs appropriate Python functions instead. Few words about features. So 0.9 was in February 2007. That was a while ago. We planned to release 1.0 before PyCon. We didn't make it, but we plan to. We plan to clean up a bit code and go. Conf tests are pretty per project, so we want to go more into plugin architecture like nose, and of course we want to have very common interface with nose. Implementation will differ, but that doesn't matter. The idea is to be able to run all of your test suite, including both nose and py.test, and well, choose whatever you like more. I think this is it.
Yep. Okay, and so we kind of tried to keep this short, thinking that there would be questions and such, so this is a good time for questions. If you've got a question, she'll bring the mic around. And the website for py.test?
It's codespeak.net/py. That's like this.
Yep, I'll take the mic. Yep, so this is the address, and there's good documentation there. I think there's...
All the presentations are in SVN on the codespeak.net, so you can just grab the slides. They're all MIT anyway.
Are there any tools for converting unit tests to py.test?
Yes, there's one tool for converting and the other tool for running them. So we can run them directly, and we can also convert it. We use the tool for converting to convert all C-types tests from Python regression test suite into PyPy test suite.
And as a user, I can say it worked for me once. It was awesome. So the question was, this is very similar to nose, so what's the point in creating this instead of nose? Py.test was actually implemented before nose, and nose basically said that's a really good idea, and we like to make it a little simpler in some cases. So the big differences from my perspective as a user are py.test does this introspection magic, which makes it very, very easy to tell exactly what's going wrong when the failures happen. And that's the biggest thing that really jumps out at me. There's other, like all of the distributed testing, you know, all the web stuff, all the stuff in the second half of the talk is kind of py.test specific. But, you know, they try to be very, very similar. And we're going to actually try to make them more. So that way, if you are a more advanced user, you can get full value out of it. And if you just want, you know, like a smaller install, you can do that as well.
Yeah, and actually nose is way better in having nice website and having it to install easily and stuff like this. So we are a bit worse than that.
So the question was, have we thought about doing the nose.test style tags? Is that correct? Yes. And in fact, I think we're going out to dinner with the nose guy tonight, and so we're going to try to make like py.test.skip and py.test.raises and tags kind of things, see what it would take to kind of converge on a standard way of doing things.
Can you maybe tell a little bit more about the distributed testing? I mean, can you like distribute to multiple different platforms to do your unit tests on different platforms?
Yes, you can. Basically, there are some. We use it for py purposes. It's not released in a way that it's nicely documented and stuff like this, but it's tested and it's working, and we use it. It's kind of development that we would like to happen, to develop more documentation about different features that we happen to develop at some point for our own purposes, but they're not in the wild right now. But yes.
And actually, as a follow-up, depending upon how you define platform, if you mean different versions of Python, that's really easy to do. So you can actually run the same test suite on Python 2.2, 2.3, 2.4, 2.5, 2.6. I think 2.6. Maybe when it, not okay, not yet. But and PyPy, you know, all in the same test suite in the same run to see, you know, if they all work. You know, whatever your like last supported version of Python is for your app, you can actually test all of them at once.
And second question, sorry. Do you know the Selenium grid? Are you familiar with that? Okay. Then I'll just skip the question.
Okay, so list and dictionary is really easy. You just say list equals list. Dictionaries have ordering potential kind of things, but you can actually say the dict equals the dict as long as you don't work on the repr of it. And then for raises, actually, yes, that doesn't work so well with assert. So we didn't show a demo of that necessarily, but there's a py.test.raises, and you then put in the function you want to call and what you expect it to raise, and it will do that. And in the meantime, for people who like their tests to run under py.test and knows, because the raises syntax is currently different between the two, you can do a workaround where you do a try, the thing you want to do, accept, and then pass if you get it, and then like the second line of the thing is actually like, raise an error of your own. So it's kind of a hack, but if you want to be perfectly compatible. But this is how you write an exception that you're expecting.
Hi, so at my company, we currently have 4 different unit test frameworks. py.test is my favorite of them. I'd like to converge all the tests into one framework. The one thing that keeps us from doing that is that the only thing that can test twisted deferreds is twisted trial. py.test can't do that. Is there any thought of supporting that?
There was some guy trying to integrate py.test and twisted test suite. I'm not sure about the results, but yes, he's somewhere around here, or at least on the mailing list. I can check on the mailing list. But yes, this is important part.
You had something up on the screen about the technology you use for your distributed running, and I missed it. It went by too fast. Could you maybe go back to that?
To what exactly?
There was some buzzword that was describing how you do your distributed testing. py.execnet. What's that?
Okay, so maybe I'll give a user description. I'll give a user description, then he'll tell you what it really is. So py.test is part of the greater pylib, and there are some other really amazing features in pylib. One of them is py.execnet and greenlets, which let you do little stackless kinds of things. And there's also py.magic, which you can avoid or play with.
So execnet is the way of having some you put the string with your Python code, and it gets executed on the other side of the channel, where channel can be popen, SSH, socket, whatever, and you communicate over with simple data over it. So it's a lightweight remote execution protocol. You basically SSH and then run Python on the remote side.
Which means that your client is defining the protocol, which is kind of magic. So you create a little server for yourself. So on the Pi website, codespeak.net/pi, in the execnet section, there is like a 10 or 20 long file server implemented in execnet. It's kind of interesting.
Does it play well with stackless?
Does it play well with stackless?
Yeah, I think so. We are testing stackless features of Pi by using py.test, so it should.
Any other questions? Yeah, one more.
It's maybe a little unrelated, but I was wondering if we could maybe see the Python code that gets translated to the JavaScript. I'm just curious what that would look like.
That's a part of PyPy which I developed at some point, but I'm not completely proud of it right now. It's translating restricted Python, RPython, to JavaScript, but it seems that JavaScript is way too dynamic for RPython. So it's kind of worked for us when developing py.test distributed features for the web reporting stuff, but I don't think it scales, like, honestly.
Anything else? Okay, thank you very much.